Hi guys, I hope you are all doing well. Let's see today's question. So today's question is from the topic of determinants. And in this question, we have been given a determinant that says, so we have been given a determinant that is 3a, 3b and 3c. This is given to us as minus a plus b. This is minus a plus c. This is minus b plus a and this is minus b plus c. This is given to us minus c plus a and this is minus c plus b, right? So this is the determinant given to us. We have been asked to find the value of the determinant, which is given to us in the options. If you see, some number is mentioned here and in the bracket we have been given the same brackets, that is a plus b plus c, and the other bracket is ab plus bc plus. Right? And here we have various numbers like 1, 2, 3, 6. So we just need to find what numbers should come here. So I get the correct answer for the question, right? So let's first understand how to solve this determinant. We will need to use some properties of determinants here. Let's use them and let's try to find out the value of this entire determinant in this form, right? Let's start the question. So first step, what I can do in this question is, if I see all of the terms, all the diagonal elements are multiplied with 3. So A, B, and C are respectively multiplied with 3. And all the non-diagonal elements, if I see in the first column or in the first row, basically, I have minus A and I can see B and C added, right? So if I add all the three elements here, so basically I can add C1 plus C2 plus C3, that will give me 3A minus 2A, that is A, plus B plus C, right? Similarly, here also if I add this, I get minus B plus 3B and minus B. So that is again a pattern. So that also becomes B plus A plus C. Here also I see minus C minus 2C minus 2C plus 3C. So C plus A plus B. So again, that's the same thing, right? So first idea what I can do here to understand this, I can apply this column transformation. So I am changing my column C1 to make it C1 plus C2 plus C3. So now if I see my determinant here becomes, so I'm just changing my column C1. So if I change C1, I just found out I get A plus B plus C. Here also, if I just change this to this plus this plus this, so minus b gives you minus 2b plus 3b, so plus b plus a and plus c. So a plus b plus c again. Here also, a plus b is present already, and this gives you 3c and minus 2c. So again, a c. So I get the same first column with all the same three elements, right? Other elements, I'll write it as it is here. So applying the first property of the determinant here, that if all the columns or all the elements are same here, I can just take out that element and replace this all the three elements by one. Okay? So I can take out a plus b plus c common and my determinant changes to 1, 1 and 1. All the other elements remain the same. So 3b and 3c is left here. And I have minus a plus b minus a plus c. This becomes minus b plus c. This is minus c plus b. Right. Now I have 1, 1, 1. Now what we do is, whenever we want to find the inverse of a matrix, so first thing what we try to do is we try to make our first column of 1, 0, 0, right? So basically I have already made this one. Now if I want to make this as well as this, both of them 0, I can use the row transformation here, that I can make it R2. So second row, I can make it 0 by using the first row, R2 minus R1. Also, I can use the third row transformation as R3 changes to R3 minus R. So now if I apply the row transformation, let's see what our determinant becomes. A plus B plus C is already common here. My determinant changes to first term 1, Now if I apply the row transformation R2, that is R2 minus R1, so this we already know 0. If I apply that for the other two elements also, let's see what I get. So what I get here is 3b minus a plus b. So that gives you 3b plus a minus b. That gives you a plus 2b. So the second element becomes a plus 2b. Further, what I get is minus b plus c minus a. So that gives you minus b plus c. Minus into minus becomes plus and minus. So c gets cancelled. We get a minus b. Further, for the third row also we have applied the same row transformation R3 minus R1. So again that becomes 0. This if I solve it further gives me minus c plus b minus c plus b. This gives you minus c plus b plus a minus b. This cancels, I get a minus c. And the last thing what I can solve here is this 3c minus c. So that gives you 3c plus a minus c. So it is a plus 2c. So now I have this determinant with me. If I want to solve this further, let's see how to do that. Delta becomes 1, 0, 0. Then it was minus a plus b and minus a plus c. And then I have a plus 2b, a minus b, a minus c, and a plus 2c. Right. So that's correct. Now let's see how to solve this further. So if I want to expand it, right, I can write this as 1, 2, determinant of this entire thing. So that is a plus 2b, a minus b, a minus c, a plus 2c. Right? After that, if you write it, it becomes minus of minus a plus b into determinant. When I have this, I'll have the determinant of this as well as this. But if you see 0 into this is 0, minus 0 into this is also 0. So entire expression becomes plus. Minus a plus c. Again, I will have the determinant of this four elements with me. And when I solve this, 0 into a minus c is 0. 0 into a plus 2b is also 0. So that also becomes 0. So you have all of these terms vanished. You only have to solve this much part. And this entire determinant was previously multiplied with a plus b plus c. So if I multiply the entire term with a plus b plus c, let's see what. So first term we have already with us a plus b plus c. Further, if I solve this, what I get? So 1 into, now if I solve this, I get a plus 2b, a plus 2c, and minus a minus b into a minus. So if I solve this further, we'll get the answer for that. So let's solve that. This is 0, this is 0, so we do not have any concern with that, right? Let's see. So delta's value now I have is a plus b plus c. And in the bracket, I have to solve a plus 2b into a plus 2c. So a plus 2b into a plus 2c minus a minus b into a minus c. So a minus b into a minus c. That's all. So a plus b plus c. If I multiply this, a gets multiplied with the whole bracket. That makes it a square plus 2ac. Then this 2b gets multiplied with this whole bracket. That makes it 2ab plus 4bc minus. This gives you a into a minus c, that is a square minus ac, minus b into a minus c, that is minus ab plus c. Further, a plus b plus a square and minus a square again c and cancel that directly. Right? Now 2ac plus 2ab plus 4bc minus, I have here minus minus, so plus ac plus ab and minus bc. Now what I can solve it as is a plus b plus 2ac plus ac 3ac, 2ab plus ab 3a, 4bc minus bc plus 3. So if I take out 3 common, I have a plus b plus c. I have AB plus BC plus C as well. So if you see the final answer which we have got was asked to us in all the four options as a plus b plus c into ab plus bc plus ca, right? But we have got it with the number 3. So the correct answer in this question is option C, that says 3 times of a plus b plus c into ab plus bc plus c. I hope you have understood how to solve this question. So what we did was, I'll explain it to you in short, that first what we did is we just added all the 3 columns in the first column. So we got the same element, we took that common. Once we took that common, we got 1, 1, 1. So we just tried to make it identity matrix. So 1, 0, 0. So to make it 0 and 0, we use the row transformations as R2 minus R1 and R3 minus. That led me to finding the value of the determinant, and that gave me the value of the determinant as 3 times of a plus b plus c into ab plus bc plus c, right? And the correct answer in this question was C. So I'll meet you again tomorrow with the next question. Till then, you can like, share, and subscribe if you're finding this helpful. Thank you.